In the previous video, we got Sonoma installed. That was quite the feat, and we did some basic function checking. Now we're going to go a little deeper into checking everything is okay, as we'll do some benchmarks. So here we go. Of course, it's always a good idea to have the ability to monitor temperatures and things like that. So on the Mac side, you can actually run Intel Power Gadget. It's a little tricky to find, but I have the link. So you can click here where it says macOS. And then you'll just run the .dmg file, install it. I've already done that, so it's on my system. You'll do that and then reboot for it to be active. So then you go to your applications folder after you've installed it and rebooted. So it's good to run some sort of program that taxes the system to see interesting things here in the readings. So I've launched Cinebench 24. And I'll just start the multi-core test just to see that the power gadget is working. And as expected, we see a big jump in temperature, power, everything. So even though this isn't as extensive as something like HWinfo64 in Windows, at least you can see some of the basic stats. And I'll stop that. And remember earlier we downloaded that Radeon GPU sensor. We put that in our tools folder, Radeon Gadget. So let's run that. And after you run that, it puts the widget up on the top. And again, it's more interesting to see the stats when you are running something that taxes the hardware. So back in Cinebench 24, I'm going to run the GPU test. Well, not the whole thing, just get it started and see what happens to the GPU meter. So we saw it jump up pretty quickly. So that's a pretty simple gadget just to view your GPU temperature. So nothing too elaborate, just wanted to show you those two tools to be used on the Mac side for some basic monitoring of your hardware. Now obviously there are far better options such as iStat menus if you really want to get deeper into hardware monitoring. Now let's continue verifying functionality of this setup. Given the recent news with Intel 13-14 generation stability issues, it's important to make sure that all is well with the CPU under stress, that things look good in terms of temperature and power. Puget Sound has a very interesting report out, and I tend to have a mentality similar to them in that I believe if you set your BIOS such that you're limiting power, temperature, and voltage, applying the latest Intel microcode fix, then you're setting yourself up for the best possible situation in terms of stability and longevity. So I have a whole video on this topic that you can watch if you want to, and when we ran the Windows benchmarks I also showed the Mac results, so you could also go back there, but I'll just do a review. Okay, here I am in Mac Sonoma, and I'm going to run the same test that I ran on the Windows side to assess how the new Intel microcode 0x129 fares. First, I'm going to keep the ASUS performance profile as the BIOS setting, and then after we apply the Intel fix, we'll have a sense for how performance changes. Now on the Mac side, I don't have anything like HWinfo64. I can't show a ludicrous degree of metrics, but with the Intel Power Gadget, at least we can see power, temperature, and have a good sense for some of the basic metrics as they change over these different BIOS settings. So with that said, let's first do the multi-core CPU test in Cinebench R23. And we'll skip to the end. Okay, so the test is finished up, and the first thing we notice is the power was averaging around 280, and the temperature was staying pretty consistent around 100, so that's not exactly where we want to be. And the score is pretty consistent with what you would expect on a Mac with an i7-14700K, so it'll be a little bit below what you see on the Windows side. Now we're going to apply the Intel baseline profile on the BIOS, see how that goes. And no, I'm not going to have you sit through all those results. I'm just going to show you the bottom line. If you've gone through this whole video series, then you're already up and running with the very BIOS settings you need, so you don't have to do any BIOS settings. Anytime here I talk about BIOS settings, it was just to show the differences in the test results. Here's a run through of all the benchmark results. First I want to talk about the coloring here. Reddish, that means the ASUS Enhanced OC profile. So I'm showing for the BIOS 2302 version and the 2504. The bluish color, that is for the Intel baseline profile, and I'm showing that for the 2504 BIOS. And the green is the Intel baseline profile, but the modified version with the additional settings that we made in BIOS. So on the single core side, we notice pretty much identical performance regardless of any BIOS settings we make, which is expected. What we really are looking out for is what happens during a multi-core test, because those put much more of a stress on the system. So let's look at what happens there. In the multi-core test, we see the results are a little bit below Windows, which is always expected on a Mac when running these 13, 14 generation CPUs. And what we see is that when we apply the Intel baseline, the score drops off from what we saw with the ASUS Enhanced OC profile. When we applied our modified settings, we see we gain some of that performance back, and we end up pretty much where we were when we had the ASUS Enhanced OC profile, which is a fantastic result, of course. Running Cinemesh 24, we see the same tendencies with the single core test, no difference regardless of any BIOS settings. And then when we run the multi-core test, that's when we see a little bit of a difference. So applying the Intel baseline, that drops off the performance a little bit compared to the ASUS Enhanced OC profile, and then we apply those modified settings to the 2504 Intel baseline profile, and we regain some of that performance back, so that we're pretty much where we were before we even applied the fix, which is a fantastic result. In GeekBench 6.3, we see the same exact thing with the single core result, no change regardless of BIOS. And then when we look at the multi-core result, we see the Intel profile, it drops performance down a little bit compared to the ASUS Enhanced OC. And then we apply the modifications to that profile. That's when we regain the performance back and pretty much end up where we were. Also, we want to talk about power, temperature, voltages. I can't see voltages in Power Gadget on Mac, so some of what I talk about here is for Windows, but it applies to the Mac as well, of course. And what you're seeing here, these columns show pairings of average max. So the value on the left is average and the one on the right is the max. So in terms of power, you see a certain tendency when you apply the Intel profile, the power drops off, and then we drop that off even more when we apply our modified version. In terms of temperature, we don't see much of a change when we apply the Intel baseline profile. We still see max temps going up to 100, and the averages are in the high 80s, also on the low 90s at times. Now when we apply the modified version, that's where we see the max temperatures going way down, and the averages as well staying around 80. And this results in no thermal throttling, which is the main thing. vCore I can't see on the Mac side, but what we see on Windows is obviously going to apply because this is at the hardware level. And with the Intel profile, we see that the average vCore goes down, which is one of the things Intel wanted, but the max vCore is going up compared to the ASUS Enhanced OC profile. It's getting up to 1.5 something, which isn't a very good thing. Now when we apply the modified version of that profile, that's when we see our average going down below 1.2, and also our max is no longer peaking at that 1.5-ish area. It's going down to 1.3 something. So all in all, this is a very good result across power, temperature, and voltage. For those of you looking for some hard numbers on the percentages, here they are. Bottom line, with multi-core results, we see a consistent single-digit percentage increase in performance between the modded Intel baseline with the 0x129 fix, as well as just the default Intel baseline. And compared to the ASUS Advanced OC BIOS, before any fixes applied, we end up very close back to that multi-core performance. In terms of single core performance, we see very little differences between any of these configurations. And most importantly, when we look at power and temperature, especially considering the performances that we're seeing here, when we apply our modded version of the Intel baseline profile, we get considerably lower power as well as temperature and somewhat lower vCore as well. So all around the board, this is a very positive outcome, and you should be confident applying these sorts of BIOS settings to improve your own situation. Now we'll run the GPU benchmarks in GeekBench. First, OpenCL. And this is consistent with those scores I've been seeing when I've been running the test. So 137,000 something, which is a great OpenCL score. You won't see an existing real Mac with that kind of score. So we're good here. Now we'll run the metal test. Okay, metal scoring almost 270,000. Again, that's a really fantastic score. And likewise with the OpenCL test, there is no existing Mac that performs this well on the metal test. In fact, we're looking at about low 20% better than any existing Mac on the market right now. So that's pretty awesome considering we're using a GPU that's a few years old. So I think we validated the GPU is in good shape here in the Mac. We can perform pretty much any video editing task we can imagine, and we'll also do pretty well in 3D work, so we're good here. The next thing we're going to do is check our disk speed, so we can use Blackmagic disk speed test for that. So if you Google Blackmagic disk speed test, you'll find the Apple Store hit here. So I'm going to download it. And let's open it up and hit start. Okay, so I ran enough time. We have a good sense and all looks well. And we see here from this chart, you can pretty much expect to perform any video editing task you can imagine, except for this 12K kind of nonsense. I have no idea why it shows no data for these settings here. Now we're going to run a logic benchmark test to see how many virtual instrument tracks we can run in a project. So there's a website, musicprod.com. I have the link in the description. Go there and there are a couple of project files you can download. One titled New Logic Benchmark Test 2. And then there's also this Logic Alchemy test and a Diva. I just downloaded the first two. I didn't want to get too carried away with this. And so I've already opened up the first one in Logic, and the idea is you want to see how many tracks you can have before you get dropout messages. So you need to duplicate the tracks. What I did was set it up so that there are about 450 tracks or so. And then you want to hit play and see what happens. Okay, so I got overload. Now you want to start deleting some tracks. I've just deleted about 10 tracks, and now I'm going to stop this screen recording software because that's using up a lot of system resources. So to get a better idea of what Logic can really do, I'm going to close out of that. Okay, so I find that usually I can run about 430 to 440 tracks before getting those dropouts. So that's pretty good. On this website, they list some example scores. So a Mac Pro, around 400, a little under. So I don't think you'll have any problems in Logic with this kind of setup. Now we're going to run a benchmark to see what we can expect out of Final Cut Pro. So there's a pretty well-known benchmark called Bruce X. It's pretty old, but it's still relevant today. The link is in the description. So you download the provided file on that website. And then there's some instructions. I've already downloaded it, so I'll open it in Final Cut Pro. There's a library that you download. And then you just go into the project section, load that into the timeline, and make sure you have background render turned off. And then you want to go to File, Share, Export File, and then go to Settings. Now on the website it says to test Apple ProRes 422 LT, but in my test that render happened so quickly it's pointless to even time it. So instead I'm going to use the 444XQ setting, which is a more demanding test. So I went to File, Export File, and then I went to Settings. Just make sure it's video only and that the Apple ProRes 444XQ is chosen. And then just give it some file name. And then I just used a stopwatch on my phone to see how soon it takes for a QuickTime to then launch and display the video. And that was around 5 seconds, which is a really fast render and tells us we'll be good to go when it comes to video editing. Now that we have a sense for the performance of this system, if we look at real Macs, we see the interesting fact that we would have to spend 2 to 3 times more to get the same performance. So even though Apple Silicon is way ahead, in August 2024, you can still build a kick-ass Hackintosh that is incredibly well-performing and incredibly cost-effective compared to real Macs. And that's it. We've covered a ludicrous amount of ground, and if you stuck through the whole series, you now know what's entailed in building a computer, getting it set up with Windows and Mac to do audio, video work, or whatever kind of work you need to do. And that's no easy feat. You should be really proud of yourself, so good job.